Hello, everyone. We are from Team 3, a project about estimation of obesity. For today's presentation, we have 5 sessions: background of objectives, data, methodology, results, conclusion, and discussions. Obesity is a worldwide disease that affects people of all ages and gender. Based on prior studies, eating habits, physical activity, and gene are factors related with people's obesity predisposition. In this study, we are trying to find a descent model that could be capable to estimate the obesity status by eating habits, physical conditions, and other variables. With techniques of data mining, we are clustered and identified grouping structures of data based on some features, predictors. We believe such detection of obesity levels can help people to have a healthier lifestyle against this global epidemic. The data set we are using to estimate obesity level are collected from individuals in Mexico, Peru, and Colombia. It's mainly about their eating habits and physical conditions. The data contains 17 attributes and more than 2,000 records. 77% of data was generated synthetically using the Weka tool and the Smoter filter. 23% of data was collected directly from users through a web platform. These records are labeled with obesity level. That allows classification of the data using the values of insufficient weight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3. And they are divided into non-obesity and obesity. The formula of mass body index is shown here. Regarding predictor variables, there are basic variables such as gender, age, weight, height, family history of overweight, and smoke status. Those attributes related with eating habits are frequent consumption of high caloric food, frequency of consumption of vegetables, number of meals, consumption of food between meals, consumption of water daily, and consumption of alcohol. And attributes related with physical conditions are calories consumption monitoring, physical activity frequency, time using technology devices, and transportation used. Next, Jiayuan will present to describe the data mining algorithms we use in this study.
Okay, regarding the methods we used in this project, first of all, we summarized some statistics and visualized the data. We provided a histogram of the distribution of obesity levels. In addition, we assessed the relationship between obesity levels and the predictor variables. If the predictor variables are numeric, such as age, height, weight, and so on, we presented summary statistics like mean, standard deviation, minimum, Q1, median, Q3, and maximum. We also provided histograms of the means of the predictor variables by obesity levels. In addition, a correlation plot is presented for the correlations between each of the numeric variables. If the predictor variables are categorical, such as gender, family history, and with overweight, and so on, we presented histograms of the counts of the predictor variables by the obesity levels. Next slide, please. In order to achieve our objective 1, we used the algorithm of the classification by logistic regression. We coded the domain variables for the categorical predictor variables. We also defined X to be all the predictor variables and Y to be the obesity status. As mentioned, the obesity status is a binary variable, either 0 or 1. So the below step are the steps are the steps we used for the analysis. We split the whole data set into train data and test data. And we imported the logistic regression model and created a logistic regression. We fitted the model on the train set and performed the prediction on the test set. For evaluating the model, we used the model evaluation metrics such as accuracy, precision, and recall. Finally, we plotted a ROC curve, which is a plot of the true positive rate against the false positive rate. It shows the trade-off between sensitivity and specificity. Yeah, next slide. For objective 2, we use the algorithm of clustering by k-means. We applied k-means to our data to create 7 clusters. For the 7 obesity levels, k-means computed the distances between each point and assigned it to a cluster. We presented 2 clustering plots. One is to plot the clusters in the test data by height and weight features. And the other is to plot clusters with the k-means predicted values by height and weight features. Here we choose height and weight as the important features because the obesity levels were based on BMI, as mentioned before, and the BMI was derived from height and weight. In next few slides, Zihao will introduce the results of our project.
Thanks, Jiayuan. So moving to my part. So in this part, I'm gonna represent some result we got based on our method. We're using explore this data set. So first, here showing some summary statistic. The distribution of the obesity level in different predictive variables. Those variables are numerical, such as age, height, weight, etc. So you can see the graph on the left, also the statistic summary at the bottom. Next. So on this graph, we can tell the correlation between the predictor variables and between the opposite levels and the predictor variables. As you can see, the color is dark, the coloration is high. We can get a very rough conclusion that the opposite level is much more has higher correlation relationship with the weight with the weight predictor. Next. So in this slide is predicting the also the predictor variable, how the opposite level distribute between the predict variables, but these variables are categorical predictor variables, such as the gender, family history with overweight, etc. Next. So the result for our achieving objective number 1 is we using the logistic regression, get some the result. The first, evaluate the model using the model evaluation metrics such as the accuracy, precision, and the recall. For accuracy, classification rate is 99.37%, considered as good accuracy. Precision, when the logistic regression model predict the opposite, predict an opposite 99.66% of the time is correct. Recall if there are patients who have obesity in the test set, and the logistic regression model can identify it 99% of the time. Next. So another method is using the clustering k-means. So you can see the two plots. The first one in the tested data by height and weight feature on the left. The second on the right is showing with the k-means predict the value by height and weight feature. After applying k-mean to our data and creating 7 clusters. Next one. So we can jump to the conclusion that first one, the logistic regression model was a perfect classifier with accuracy of 99.37%, precision of 99.66%, recall of 99%, and its AUC score of 0.9996. This could be used to estimate the obesity status by eating habits, physical condition, and other variables. K-means clustering identified grouping structures of obesity levels data based on the height and weight features. We also found that weight had the strongest correlation with one's obesity level. Other factors may play a role as well. Example, eating habits and physical activity. That's our conclusion. So we also have some discussion regarding to the conclusion we made. So dataset features could be used both for classification and clustering tasks, but please bearing in mind that most samples were symmetrical generic. Example, they did not reflect the real world. Thus, robust conclusion will require much more representative data. Although the logistic regression model was a perfect classifier, it is still interesting to try other types of classifiers such as decision tree, etc. to compare the result. K-means computes the distance between each point and assigns it to a cluster. Thus, clustering could be considered an unsupervised learning classification algorithm. However, its performance could be assessed since there are not evaluation metrics for unsupervised training. So here's our reference. Thank you, that's all.